Hello everyone, my name is Abhishek and welcome back to my channel. In today's video, let's learn MongoDB. So this is going to be a MongoDB Zero to Hero tutorial where you will learn different concepts of MongoDB. So we will start with learning the fundamentals of MongoDB first. Then we will learn different features of MongoDB. And then we will focus on installation and configuration of MongoDB. Then we will learn how to implement CRUD operations using MongoDB. And then we will learn how to build a real-time DevOps logs explorer by using MongoDB as database. And finally, we will learn how to use MongoDB for modern AI applications, where we will learn different modern capabilities of MongoDB. For example, vector search. So this is going to be a very interesting tutorial. If you are interested in learning MongoDB from absolute basics, make sure you watch this video till the end. And before we get started, the complete notes for this tutorial will be shared as part of this GitHub repository. So you will find the detailed notes, commands that I'm going to execute, even all the configuration steps in the same GitHub repository. I'll share the link in the description so that after watching the video, you can use this GitHub repository as your revision material.
Also, I would like to thank MongoDB for collaborating with us and sponsoring today's video.
Let's get started.
So, what is MongoDB and why MongoDB? Even a quick search on the internet will tell you MongoDB is a non-relational database. Basically, it's a document style database that stores the information in JSON-like objects. To be precise, BSON or binary JSON. But the big question is, why do you need MongoDB in 2026? To understand this better, let's go back to relational databases and understand why modern applications needs more than a relational database. So we all know relational databases are traditional databases that stores the information in rows and columns. So basically, you create a table within a relational database and you store the data in rows and columns. Let's take an example. Imagine you work for an e-commerce platform and you want to store information of the users like the user data, orders placed by the user, payment information, payment status. You want to store everything related to a user. So initially, you start with creating a table within the database. Let's call this as user information table. And within this table, you start creating different columns. For example, user ID is a column. Name of the user is another column. Then you have email address of the user, which is very important. Then the mobile number of the user. Let's say you start with these columns initially. Now, when a user creates an account with the platform and starts some activity with the platform, you store the user ID. Let's say the user ID is 1. Name of the user is Abhi. Email address and phone number, which is perfectly fine. Now you have another user created account with the e-commerce platform. This time when you start storing the information, let's say user ID is 2. Name is Ram. Email address is provided. Phone number is also provided. So you might say, Abhishek, so relational databases meets the purpose. But what if this time the user Ram has 2 phone numbers? So just for user Ram, because in relational databases, schema is very strict. That is, you cannot store 2 phone numbers within the same column. You have to create another column called phone number 2. Because it is important to store all the phone numbers of user Ram, you end up creating a new column. Now let's say you deal with another user. This time let's call the user as XYZ. Email address is provided, phone number is provided, and just like Abhi user, even XYZ user does not have phone number too. But let's say the XYZ user has another email address, which is also important to store. So this time you create another column. You call this as email ID 2, and you store the second email of XYZ user. So this way, let's say you keep adding different columns for order summary, payment information, payment status. You will realize at some point with relational databases, your database is bloated with a lot of null values. So you have a lot of null values in your database, which makes your database looks large, but the actual information that you store in the database is not that large enough. So what does this mean? Your database becomes pretty complex and you have to be very good at querying the information from the database. Because of these null values, you end up having wrong information as your query output if you are not good at querying the information from the database. Now, it does not mean relational databases can't handle this situation. They can handle the situation. In fact, relational databases are designed to handle such situations. How they deal with it is by creating multiple tables within the database. So this time, instead of a single table holding all the information, you create multiple tables. Let's say the first table is user basic information table, where you have user ID, you have name of the user, and let's say full name of the user. So this becomes one table with three columns. So user ID 1, user ID 2, user ID 3, name Abhi user, Ram user, and XYZ user. Let's say you also provide full names of these users. Now in the second table, let's say you call it as phone number table. In this table, you have the ID, you have phone number, and user ID. That means in the previous example, if you notice, user Ram has two phone numbers. So for ID1, that is Abhi user, you store a phone number. You call this as ID1. But for user ID2, that is the Ram user, you have two entries in this table. So user ID2, user ID2, phone number 1 and phone number 2. Of course, the ID becomes here 2 and 3. This way, you start storing phone numbers in a different table. In the same way, you create another table for email, and again you have fields like ID, email ID, and user ID. So user ID is the one that is keeping these tables connected, right? So there is a relation between these tables. So the user ID here relates to user ID in the other table. Now, if you want to fetch, let's say you want to get the information, get me the complete details of Abhi user. So you know the user ID of Abhi user is 1. So you get name of the Abhi user from this table, full name from this table, phone number from this table, and email ID from this table. So this way, a relation is maintained between different tables in the database. That's why it is called as relational database. Now in the relational database, you have to be very good at querying. For example, you might have to use a lot of join statements to get information of a user across different tables. Now, are there any issues with the relational database? Okay, one thing you must have noticed: to avoid bloating of the database, to avoid a lot of null values in the database, you created multiple tables. But if you think this solved the issue, let me explain. This is not where the tables stop. If you want to store information of orders of the user, right? You want to store orders of each user. Again, you create a new table. You call ID, order ID, and user ID. So this time, Abhi user's information is not in three different tables, but you have another table for Abhi user, which has different orders that are placed by the user. You might have another table for payment information. You have another table for payment status. You might have another table for shipment status, delivery tracking. So this way, in relational database, you will end up having multiple tables within a database. It's not just 2 to 3 tables, but your query has to fetch information from n number of tables. What does this mean? Complexity. Additionally, with relational databases, schema is very strict. That means, let's say in this case, if user has two phone numbers, you cannot store both the phone numbers within a same column. So that's why you ended up creating a new column for the table. So this way, because the schema is very strict, whenever there is new data, you end up creating a new table, or you end up altering existing table within the database. Additionally, development also becomes difficult with relational databases because developer has to make sure data is fetched from different tables, and then the collected data is organized into maybe JSON format so that developer traverse the information that is fetched and maybe pass the information to a different component of the application. So these are some critical challenges with relational databases. Okay, but how non-relational databases address these challenges? So non-relational databases are fundamentally unstructured databases. That is, you do not store the information in rows and columns in non-relational databases. So this is a major advantage. When it comes to table, when it comes to rows and columns, you have to follow a specific schema. So your data has to be structured. If you want to store two phone numbers of a user, you end up creating a new column in relational databases. That is because of strict schema and storing the data in rows and columns format. But when it comes to non-relational databases, it stores information in formats like key value pairs or documents. Even some non-relational databases store the information in wide columns. Now, the best example of non-relational database is MongoDB. So with MongoDB, you store the information in document style. That is, MongoDB is a non-relational database where you store the information in JSON-like documents. Now, your user information, the complete information, it can be the basic information of the user, phone number, email address, orders, payments, everything is within a single JSON document. Let me show you with an example. So with non-relational databases, the JSON document of Abhishek user would look something like this. So this is the complete JSON document where you have name of the user, email address of the user, phone number of the user. Let's say there are multiple orders for the Abhishek user. Instead of one single order, there are multiple orders that are placed. So you can create a list for the orders and you can store list of orders. So this is order 1, this is order 2. In the same way, you can also store multiple payments related information. For each order, you can store the order information and payments information. Because JSON, you can store unstructured data. That is, you can store a single order, or you can store a single payment information, or you can store multiple payments information as well. This makes MongoDB or even non-relational databases pretty flexible. So you can just create a collection and you can keep storing documents for the users. So now Abhi user will have a JSON document when it comes to MongoDB. Ram user will have a JSON document and XYZ user will also have a JSON document. If you think there can be multiple phone numbers, just change phone number field from a string to a list so that instead of one phone number, multiple phone numbers can be used for the user. Similarly, you can change email address, you can change. If you think there is only one order that can be placed, just change this from a list object to a normal string object. So this is how non-relational databases can help you with modern applications. One more thing about relational databases, most of the relational databases, they are vertically scalable. Now it is not impossible to scale relational databases horizontally, but it is very difficult because of the default vertical scalability nature of relational databases. Now, vertical scalability is not very cost effective. Let's say you hosted your database on a very CPU intensive virtual machine, or you stored that on a very memory optimized virtual machine. If you start scaling the virtual machine vertically, you will end up paying a lot for the cloud provider. Horizontal scalability can also provide you advantages like sharding, which vertical scalability does not provide. So the problem here is that relational databases by default are vertically scalable. But when it comes to MongoDB especially, MongoDB major advantage is its scalability. So along with flexibility, you can also scale MongoDB horizontally across your cloud provider or on MongoDB cloud. Now, because it is horizontally scalable, you can also bring in the capabilities like sharding. So this is about relational and non-relational databases and why you need a non-relational database like MongoDB for the modern applications. Now, before we move ahead and learn MongoDB in real time, let's focus on 6 important building blocks of MongoDB. We will start with database first. So just like relational database management systems, even in MongoDB, a database is a top level container to store the information or your data. Let's say you work for an e-commerce application and you want to store information of the users. The first thing that you do is create a database like user database. Then you have something called collections. Collection in MongoDB is basically like a folder within your database. Then there is something called document. Document is basically to store information of individual users in this case. Let's say you want to store information of 3 users. You create a document for each user. So a document for, let's say, Abhi user, Ram user, and XYZ user. Each document has the complete information of the user. So basically you start with creating a database, then you create a collection to store all the documents, and then you create document for each user. And these documents, when it comes to MongoDB, in JSON-like format, to be precise, BSON or binary JSON. Then there are fields within the document. In this example, for Abhi user, there is a field called name, there is a field called phone number, and maybe fields like email address, etc. So within the document, you basically have the fields. Now, another important building block that you need to know is BSON. You know JSON? What exactly is BSON? Very simple. When you deal with MongoDB, You typically perform the read and write operations in the JSON format, but how MongoDB stores the information internally is in the BSON format. Let's say you want to create information related to a user. You store the information in the MongoDB or you share the information to the MongoDB in JSON like format. MongoDB takes that information and internally it stores the information in binary JSON format, which we usually call as BSON format. So JSON is user readable format and BSON is machine readable format. Finally, schema. But Abhishek, I thought MongoDB comes with flexible schema. When you are dealing with MongoDB, I thought schema is not required. Let me tell you a very important thing here. In MongoDB, schema is not mandatory, but if you want, you can implement schema validation with MongoDB as well. That is, whenever you create collections in the MongoDB, you can set up schema validation for documents that you store within the collection. Let's say you want to define certain fields in the document as mandatory, or you want to define particular data type for fields within your document. You can also do that with MongoDB. So what I'm trying to say here, schema validation can still be implemented with MongoDB and it can be enforced during the creation of collection. So these are 6 important building blocks of MongoDB. Now for simplicity, I will try to compare this with relational databases. If any of you come from the world of relational database, this comparison makes it simple for you. Let me tell you, this is not the one-on-one comparison because relational databases and non-relational databases are different. This is just for your understanding. Databases are very similar to databases in relational database management system as well. Collection in MongoDB is just like a table in your relational database. Document is just like rows within the table of your relational database. Fields are basically like the columns within your relational database. JSON, as I told you, is how the data is stored internally within MongoDB. So that's not required. So you can understand database as database, collection as a table, document as rows in your relational database, and fields as columns within your relational database. Now that you understood the building blocks, let's go ahead and set up MongoDB instance. When it comes to setting up MongoDB, you can do it in different ways. Just use the link in the description or pinned comment and click on the products tab. Let's explore different ways of setting up MongoDB. One is community edition. So community edition is completely free. If you're interested in local development with MongoDB, so you can download the community edition, install MongoDB within your virtual machine, laptop, container, anywhere. But with the community edition, you have to take care of infrastructure for your MongoDB and you also have to take care of keeping your MongoDB version up to date. If you don't want to manage this, you can go with MongoDB Atlas. So MongoDB Atlas is a managed MongoDB instance. I mean, you can get a managed MongoDB instance using MongoDB Atlas. On top of that, you also get capabilities like using the Atlas CLI. So you can basically spin up the managed MongoDB instance using the Atlas CLI, or you can use Terraform to spin up a new MongoDB instance. You can use AWS CloudFormation template, even Kubernetes operator. So you don't have to use the MongoDB user interface every time to spin up a database, but instead you can automate this using infrastructure as code as well. It's very easy to get started with MongoDB Atlas. All that you have to do is to create an account with Atlas and spin up your managed MongoDB instance. Now, when it comes to pricing, if you want to get started, the good thing here is you can get started for free. No credit card required. You can just explore Atlas with storage of 512 MB, shared RAM, and shared CPU. Once you are comfortable, only then you can upgrade to the Flex version or dedicated MongoDB Atlas instance. Now let's create an account and get started with MongoDB Atlas. So I'll create an account, get started. I'll use sign up with Google. Perfect. So my Atlas account is created. I'll skip the personalization and I'll proceed with creating the MongoDB cluster. As I told you, you can go with dedicated cluster, flex cluster, or even a free instance of MongoDB. I'll choose a free instance for now. So it says free forever. Your free cluster is ideal for experimenting in a limited sandbox. Cool. Name of the cluster, I'll just call it as demo cluster. The best thing here is that MongoDB, although this is a managed MongoDB instance, it provides you an option to choose between different cloud providers where you want your MongoDB instance to be hosted. I'll go with AWS as the cloud provider and I'll use Mumbai as the region, something that is nearest to my location. That's it. I can click on create deployment and in next 2 to 3 minutes, I'll have my MongoDB cluster set up. Just make sure one thing, copy the username as well as password, right? Just copy these details and click on create the database user. This is very important because with these details, we will connect to our MongoDB instance later. So I'll just copy these instructions for now. Create database user, choose a connection method. There are different ways how we can connect to the created MongoDB instance. So we can connect to that through the drivers that is within the source code. We can use the user and the password that we just got, or we can go with the tools like MongoDB Compass. I personally would recommend this. This is like MongoDB's graphical user interface. It's very easy to get started. So just download MongoDB Compass. I don't have Compass installed. Go with this option. And according to your laptop or according to your instance on which you are installing MongoDB or from where you want to connect MongoDB, select the package type. In my case, Mac OS, ARM64, Apple Silicon. So I'll just download the latest version of Compass. Click on the download. There you go. So I have the DMG file getting downloaded. Again, I'll just copy this connection string. Perfect. Click on the done. So if you go back, you can see the demo cluster is set up, but still sample dataset is loading into the cluster. So some operation is still in progress. In the meanwhile, let's modify the network access. So basically, the demo cluster is almost ready, but to make sure you can connect to the demo cluster, just head to the network access, click on IP access list, and make sure from wherever you want to connect this cluster. If it's your personal machine, make sure your personal machine IP address is in the access list entry. If you're not sure, and if you're just starting or if you're just getting started with MongoDB, click on allow access from anywhere. On your production system, you have to make sure only a particular CIDR is allowed. Click on confirm and that's it. There we go. Just in few minutes, MongoDB cluster is ready and sample dataset along with the search index is successfully loaded. Now let's connect to the cluster using MongoDB Compass, the one that we downloaded. It's very simple. Click on add new connection. remove the default connection string, and paste the one that you copied during cluster creation. So paste it here and click on Save and Connect. That's it. Now your Compass is connected to the cluster that you set up in your Atlas account. Let's explore the cluster. So this is the name of the cluster, and within the cluster, there are multiple databases. Admin database, config database, local database, and sample mflix database. This is the one that is loaded using the sample dataset. Now what's in the database? As you must have guessed, database has different collections. This is what we learned during the building block section. Database is a top level container which has multiple collections. Now there is users collection, theaters collection, sessions collection, movies, and comments collection. If you click on one of the collection, you can see different documents within the collection. Because we opened the users collection, you can see 185 documents. Each document is related to the user information. So this is a document for NetStack. This is a document for Robert user. And this is a document for Jamie user. And within the document, there are multiple fields. This is the name field, email, and the password field. These are the building blocks of MongoDB. Along with that, you can also implement schema validation. For example, you can generate some rules or you can add your custom rules as well. Now, once you add these custom rules, the schema validation will be applicable for the newly created documents. If you need, you can make the schema validation strict and you can apply the schema validation to the existing documents as well. Now, the best part about MongoDB Compass, you can not only read the information of the documents, but if you want, you can also update the documents. So I can just make a change and click on update the document. Not only that, I can also create a new database, similarly, a new collection as well. So this is the reason why MongoDB Compass is best suited for the beginners. It's very easy to get started. On top of that, within the MongoDB Compass, you can also open the MongoDB shell. So let's say you want to run some queries or maybe you want to fetch some information through the CLI. You can also do that within MongoDB Compass. For some reason, if you can't install MongoDB Compass and if you just have access to the MongoDB Atlas account, even from here, you can connect to the cluster and you can explore your cluster. Very simple. Just head to your cluster, click on Browse Collections. Now, once you click on Browse Collection, you can see you are connecting to the demo cluster. And once you are connected, just like MongoDB Compass, you have the visual representation. So I'll click on Sample mflix. I can click on Collections and I can explore the different documents. Even here, I can perform the read as well as write operation. But in most of the cases, when you work in your enterprise, you might not be granted this access through your Atlas account. This access is usually restricted. Okay, now that you learned how to create a cluster, how to connect your cluster to MongoDB Compass, and also how to use the cluster, let's go ahead and learn some MongoDB commands, and then let's learn CRUD operations using MongoDB. So first of all, I'll go back to my MongoDB Compass, and on the cluster, you would see a shell icon. Click on the shell icon. Okay, so now you are connected to the cluster using MongoDB shell, but you are not connected to any database. So let's start with understanding how to connect to a database. So I'll walk you through some basic MongoDB shell commands before we head to the CRUD operations. Okay, so the first thing you do to list out all the databases, is run this command show databases. This comes with auto completion feature, so you don't have to literally remember every single command. Even if you remember the command, the initial part of the command, auto completion can help you complete the command. Okay, so show databases can show you the list of databases. And let's say you want to connect to a database to run some query. So you can use this command, use, let's say I want to connect to sample mflix database. So I'll just say use sample mflix. Perfect. Now I'm connected to the database. Let's say I want to get only one document. Okay. So, if you want to get all the documents, it's very easy. You can just run tb.users.find. Okay. So this will get all the documents. It's pretty easy. But let's say you want to get only one document. You want to get the document of the user, maybe net stack. How do you do that? So you can run this command. Going back, I'll clear the screen. CLS db dot users. So within the users document, find open close braces, and now use the JSON field. So I'll pick up the JSON field name. Okay, so name, because this is a kind of unique JSON field and I want document of a particular user, I'll just provide the name of the user. So if I want name of NetStack user, I'll just copy this and paste it here. Now let's see. Tada. So we got the document related to a specific user. So these are some basic query commands that you need to know before we head to the complex CRUD operations. So what did we learn? So we learned how to list the databases. We learned how to connect to a database using the use command. Then we learned how to list the collections. How do you do that? Show collections. So this will list all the collections within a database. And within a collection, if you want to look at the documents, just use the find command. And if you want a specific document, use the find command with a field within your JSON document, such as name Abhishek or name Rahul. That will fetch you document of the specific user. Moreover, if you're using Compass, let's say you don't remember a specific command, you don't have to go to the MongoDB documentation or any resource on the internet. You can just use the MongoDB assistant. Let's say I'll ask the MongoDB assistant a simple query command like ask it what is the command to get a document within a collection. Okay, so MongoDB assistant is thinking. It can also help you with the queries. So it says to get, you can use the find command and you can use the field name and value. So it comes with auto completion and also AI assistant. So this is the added advantage if you go with MongoDB Compass. Anyways, let's move to the next step, that is CRUD operations. What is CRUD? CRUD stands for create, read, update and delete. Typically, every single operation that you can perform on a database. We will start with create or insert operation. So for that, I'll connect to the cluster from the shell one more time. And I will use the sample mflix database. So use sample mflix. Perfect. Now let's create or insert a document to the users collection. At this point, each user here has a JSON document. So I'll try to add a new JSON document per Remo user. How do I do that? So I'll use the command db.users. So the name of the collection to which we want to insert the document. dot insert one. Okay, so insert one will help you insert a document into the collection. Open close braces and in the JSON format. Okay, we have to add the document in the JSON format. So in the JSON format, add the new user. I'll provide name of the user. So I'll call this as Remo user and I will provide email address to the user. So email, let's call this as remo@aqua.sh. Let's press enter. There you go. Now a user is inserted into the users collection. We can quickly verify. Go back and here you can use the query parameter name Remo. Okay. So you can see Remo user, a document is added for the Remo user. Now what about adding multiple documents at once? Because when you are dealing with databases, you might not want to create a single document every time. You might also want to create multiple documents. Even you can do that. Only a simple change. Instead of using db.users.insert1, this time do db.users.insert many. So using many, you can add as many documents as you want. Because we are dealing with multiple documents, you have to use a list of JSONs. So I'll press enter and I will use a list. Within this list, I will add multiple JSONs. So this JSON is for user 1 and this JSON is for user 2. Let's try to add. So I'll provide the name this time as Ramo and I will provide the email address email ramo@aqua.sh. Okay, let's do that. aqua.sh. Now for the second user, again, let's provide the name. Okay, so name, I'll call the username as, okay, I missed the double quote here. I'll call the username this time as John O. And the email address, email, instead of a single email, let's try 2 emails. Okay, but Abhishek, how can you do that? You can actually do that because the users collection that we are using is with flexible schema. That means you haven't enforced any schema validation. So you can create users with 2 fields, you can create users with 3 fields, and even within a field, you can have for one document the email field as a string, and in other document, you can have the email field as a list. So I'll go with the list this time for the second user. So email and within the list, the first one, John O at aqua.sh and comma separated the second email address, John O at gmail.com. Okay, I missed the double quote here. Let me fix that and see if this works. One more time. So we are creating 2 documents this time, one for Ramo user, one for John O user. For Ramo user, I'm only providing name and email address. For the John O user, I'm providing it with name and multiple email addresses. Let's see if MongoDB can store this unstructured data. Enter. There you go. Now you have 2 new documents added to the collection. Let's verify. Name, of course, double quote, name, and I will provide the name as John O. I hope this is the correct name. Let me just re-verify. Okay, so John followed by small o. You have to be very careful when you provide the values to the field. Okay, so ID is created, name is John O, and within the email, this time this is an array with two email addresses. If you search for Ramo, name and email, but this time email is a string. This is the importance of flexible schema. But saying that MongoDB supports schema validation. A lot of people get confused with it. That's why I'm repeating this. By default, MongoDB comes with flexible schema to store unstructured data. But for your business critical use cases, or if you need a well-defined schema for your documents, you can enforce schema validation within MongoDB. Perfect. So this is about create operation. Insert a document, insert multiple documents. Now let's move to the read operation. So we are done with C of CRUD. Let's look at R of CRUD. We already looked at the read operation roughly, but let's do it again. Let's read a single user from the collection. Okay, so we did it from this query provider. Let's do it from the command db.users.read or find, my bad, db.users.find. Let's provide the name. So I'll just say name within the JSON, close the JSON bracket, and name as John O. So even from the command, you can get the same information. But read operation is not that simple. Sometimes with read operation, you might want to get multiple documents at once. Not all the documents, but multiple documents. How do you do that? If you look at the movies collection has 21K documents. Now, out of these 21K documents with different movies, I want to filter, or I want to get movies with rating G. So this movie here is rated as TVG. This movie here is just rated as G. And this movie does not have a rating itself. So we have mix of movies. I want to get all the movies with a particular rating. Let's say rating G. It's very easy with MongoDB. All that you have to do is again db dot, this time the collections is movies, collections movies dot find, provide the field that is common across multiple documents. Okay, what is the field within the JSON? Rated is the field, and value that we are looking for is G. Let's see if we can get all the movies. Okay, so we got movies with rated G. Okay, that's fine. But if you see, we got a lot of fields, because typically in the movies collection, we have each document with multiple fields. What if I want to only get the output with certain fields? So I want to get all the movies with rated G, and I only want the name of those movies. So instead of looking at all the information like what awards did that movie gain, in which year the movie released, what is the IMDb rating of it, I only want movies that are rated G and the name of those movies. How do I do that? So I have to slightly modify my command here. So I'll clear the screen. db.movies.find, the same find command. This time, instead of just providing the JSON field, also provide the fields that you want. So within the braces, provide a JSON field, that is the rated field. Along with that, comma separated, also provide the fields that you are looking for in the output. So I can just say rated G. This is the input field, and in the output, I just want title 1. Okay, so 1 here represents that you want the title field. There you go. So this time we got the list of movies. So these are the names of the movies that are rated G. So I eliminated all the fields that I don't want to see. This is how you can define the output that you want to see using the find command. Or this is how you can get the required output from the read operation. Perfect. Let's move to the next operation, that is update operation. Very simple. You want to update a specific field within the document. Let's say within the users. So we created Ramo user. I want to update email address of the Ramo user. How do I do that? Now this is a very important operation because a lot of times you update things to the DB and later you might want to update the value of the key that you added, or you want to update specific thing within the document. Let's see how to do it. So we will go back to the shell and use db.users dot, you can guess, update 1. So just like how you insert one document, you can also update a specific document. So you have to provide through JSON which document you want to update. So I want to update document with name Ramo. Okay, so name is, key is name, value is Ramo, and what do you want to update? I want to update the email address of the Ramo user. So comma separated, just use the set command. So dollar $set followed by whatever you want to update. In this case, email colon, change the email ID to ramo@gmail.com. So previously, if you look at this user, ramo@aqua.sh is the email address. I want to change this to ramo@gmail.com. Okay, just I'm cross verifying if the name is right. Cool. Let's run this command and see if the update operation works. It says acknowledge true, modified count 1, that is a specific field is modified. Let's verify. If I go back to the query here, the query field here, and if I query one more time, name colon Ramo. So we should see instantly the email address is changed. There you go. So from ramo@aqua.sh, it is changed to ramo@gmail.com. This is how you can perform update operation. Finally, let's look at the delete operation. Delete operation is pretty straightforward. Let's say if I want to delete the Ramo user. So I'll go back. I'll just run db.users.delete1. Of course, I can delete many, just like how we are performing insert one, insert many. In the same way, I can also delete many, which I'll show you next. For now, I'll use delete one, open braces, in the JSON format. Choose a field that will delete the specific user that you want to. So I'll go with name Ramo. Okay, so within this curly braces, I'll just say name and the value of the name as Ramo. Enter. Okay, so it says acknowledge true, deleted count is 1. Let's verify. If I rerun this query, I should not see the user. That's it. Now let's see deleting multiple users, right? So let's say you want to delete, let's go to the movies collection this time, and you want to delete all the movies with a specific field, a common field. So you want to delete all the movies that are released in the year 1903. Okay, so let's see how to do it. We will do db.movies.delete many followed by within the braces, no, the JSON field. I think it's year. Let's cross verify. Yes, year 1903. Let's provide that colon 1903. Okay, so there is only one movie in the year 1903. So only one movie is deleted. Let's try a different year. This time I'll go with year 1992. Let's see. So there are 270 movies and all the movies with the year 1992 are deleted. I mean, which are released in the year 1992 are deleted. You can verify if we go back. Let's query here year. Okay, 1992. We should not see any movies with that specific year. In the same way, even if I query 1903, I should not find any movies. So this is how you perform delete operations as well. So we learned create, read, update and delete. It's super easy, right? So this is because of the JSON format. Now let's move ahead and understand how MongoDB is used in real time. I'll take a very interesting use case, that is MongoDB as log explorer. What exactly does it mean? Now if you look at any company today, so companies deal with microservices. For example, e-commerce platform. An e-commerce platform is made of multiple microservices and each microservice omits some logs. Now these logs have to be stored because let's say you run into an issue on the production. Now the first thing that you want to check is the logs of the services. If you don't store historical logs, then it becomes very difficult for you to understand what is the actual reason for the error. It's not only error, maybe at times you want to look at a pattern within the logs. So you want to look at the historical logs, maybe logs of last 10 days, logs of last 15 days from various services to understand any common pattern. It also can be to understand network latency, to understand any issues with the memory. For any of these use cases, you need to store the logs. So this is where MongoDB can help organizations. But Abhishek, why to use MongoDB for storing the logs? Why not go with any relational database? So the reason is simple. When you look at relational databases, they are good at storing the information in rows and columns, structured data, but logs are heavily unstructured in nature. One log can be info log. It can be a basic log with timestamp, log with name of the service, and log message. But another log can be an error log with huge stack trace. So this log can have a huge JSON information, which is a stack trace error. And another log can be a warning log. Other log can be log with a lot of metadata. So each log differs from one other. So you definitely need an unstructured database for storing the logs. But Abhishek, even in the unstructured databases, why should I go with MongoDB? The reason is simple. MongoDB stores these log messages in JSON format as documents, and application developers, it is easy for them to store the log messages in the JSON format because all that they have to do, they have to change the format of the log to JSON, which they are already good at, and then make an API call through MongoDB client to the MongoDB database and the collection. And the best part here is some of the log packages today, the libraries, they already provide the logs in the JSON format. In this case, it's even easy for the developers. They have to take this log in the JSON format, and using the MongoDB client, they have to push the log to the collection. So that's why MongoDB is a very preferred choice. I also explained during the beginning of this video, MongoDB can be scaled horizontally. You can use sharding with MongoDB. So even if your application scale, if you have requirement of scalability, MongoDB can scale along with your application. Again, this makes MongoDB a suitable choice. Perfect. Now let's see this example in real time. So we will create a database within our Atlas cluster. We will create a collection for our logs, and then we will push the logs to this collection. And we will do this in two different ways. I'll show you how to push some logs manually through MongoDB commands. At the same time, I'll also show you using a Python application. So I have a demo Python application that can simulate a real-time behavior. Just like how in real time, you get logs from 20, 30 microservices. This Python demo application that I have, it will simulate the behavior. It will push the logs to MongoDB as if the logs come from different microservices. And it will also push logs at different levels, like the info log, error log, so that we can visualize different types of logs within the MongoDB collection. And once we have the logs in the Explorer, we will also see how to query the logs. You don't have to copy the Python application, or you don't have to write the Python application by looking at the video. I already pushed this application to our GitHub repository. So I'll take the MongoDB Compass. I'll take a new session with the cluster, and I'll start with creating the database. It's very easy to create the database. You can just use the use command. So use, I'll call the name of the database as DevOps_logs. That's all. So now a new database is created, and here I'll create a collection now. So to create a collection, db.create collection. Within the braces, just provide the name of the collection. I'll call the name of the collection as logs collection. So now we created a database, and within the database, we created the log. Now let me push some dummy logs to this collection. How do we do that? We learned this during the create operation in CRUD. We will use insert many to insert multiple documents. So db.logs.insert many. This is one document for a log message. This is other document for a log message. Let's run this command. So it says both the log messages are inserted to the database. On the left hand side, I'll rephrase the cluster. Okay, now along with sample mflix, I can also see DevOps logs database. Within this, we have the logs collection, and within this, we have both the logs. Now using the query field here, I can query for error log, or I can query for info log. Of course, at this point, I just have two log messages. Once we use the Python application, you will see this log explorer flooded with hundreds of logs. Let's do that. So now I'll take my terminal this time, and within the terminal, I'll start with creating a folder. mkdir, I'll call the folder as DevOps logs folder. Okay, let me create DevOps log. I'll switch to this folder, and I will start with creating the Python virtual environment. Python 3 -m venv space dot venv. Okay, now let's source the virtual environment. Source dot venv bin activate. Now once the Python virtual environment is activated, before you write your Python application, you need a Python dependency to connect to the MongoDB. right? So within your Python application, to connect to this MongoDB database and collection, you need a MongoDB client. In Python, the client is PyMongo. PyMongo is a package that provides the MongoDB client. How do you install that? Just run pip install PyMongo. That's it. This will install the dependency for us. Now I'll use the Python application. Vim, I'll just call it as demo.py. And here I will paste the application source code that I already have. Very simple application. These are the dependencies. The important dependency to note here is PyMongo, which provides us the MongoDB client. Now this step here is to connect to the MongoDB. In our case, we should update the connection string. This is connecting to the local MongoDB instance. If you're using a local MongoDB, you don't have to change this, but I will update my connection string here. There you go. And then we are connecting to the database as well as the logs collection. Now this is the interesting part of the application. So basically it is simulating different microservices, auth service, payment service, order service. And it is simulating different levels of log messages: info log, error log, and warning log. Now for every 2 seconds, we are using the while condition. So till the time application is in the running state, for every 2 seconds, it will generate a random log message choosing a random service, and it will push that to the database. Logs.collection, insert one log. So one log at a time, every 2 seconds, this will push a random log message choosing random service to our MongoDB collection. Let's see. So I'll save this application and run it Python 3 demo.py. Let's give it some time because it is pushing a log message every 2 seconds. Let's at least wait for 30 seconds. So we have 15 log messages within our MongoDB collection. Fair enough. Now we have a good amount of log messages. So let's go back to the MongoDB compass. Now if I remove the query and refresh this, you will find a flood of log messages. This is what happens in real time. This is how MongoDB can be used as log explorer. Now you have all the logs at one place. Let's say you want to query the logs of payment service, right? So you want to see all the log messages from parent service. Just copy this and paste it here. Service, payment service. Okay, now we should see the messages. All of them are from the payment service. Let's say you want to see log messages from order service. I guess the name is correct. Okay, let's look at the name of the service. So it should be order service, right? Order service. So let's change that in the compass and we should see all the log messages from order service. Now let's take a real-time problem statement. Instead of just querying using the service name or querying using the log level, let's say your production instance, you notice some issue with your production instance from the last 10 minutes, and you want to see what exactly is the issue and you want to start troubleshooting from the logs. So you want to get the logs of the last 10 minutes. How do you do that? So you can go back to your shell environment and you can run a simple find command. We learned this during the read of the CRUD operation, db.logs.find. Now I'll use the timestamp field here and I am searching for the timestamp for the last 10 minutes. Now this will give us all the logs for the last 10 minutes. So this is how MongoDB is used as a real-time DevOps logs explorer. Okay, so this is about traditional applications. We looked at a traditional use case. What about modern use cases? I mean, what about AI applications? Let me tell you, MongoDB today is very widely used by developers, even in the space of AI. I'll talk about the use cases. I mean, the use cases where MongoDB is quite popularly used. But before that, let's understand why MongoDB for AI applications. So when you deal with AI applications, you deal with multiple types of data. If you take an e-commerce platform, for example, let's say an organization dealing with e-commerce platform wants to introduce AI assistant to their platform. Now, this AI assistant has to store different types of data, something like operational data, basic information like the user information, orders information, products information, regular operational data. It also has to store the metadata information like the timestamps, tags, context. On top of that, it also has to store the chat history. Now, chat history is important to keep the conversation live and also to understand the previous questions of the user. Now, most importantly, apart from all this, the AI assistant also has to store the embeddings, or it also has to deal with the vectors. This is where it becomes challenging for other databases. Now you have a lot of other databases that can deal with operational data, but they might not help you with the vector information, or they cannot be used as vector databases. And this is the advantage with MongoDB. MongoDB can store your operational data, and it can also store your vectors or the embeddings. But you might say, Abhishek, what if we go with two different databases? One, the regular non-relational database, and other vector database. You can do it. You can in fact go with two databases. That's the mistake a lot of companies do as well. Now with two databases, you introduce new challenges to your organization. Something like scalability challenges. Now with two databases, you have to deal with scalability of two databases. As you scale your AI assistant, you have to scale your regular database, and also you have to scale your vector database. And on top of that, you also have to deal with extra network calls. That is, you have to deal with extra latency challenges, you have to deal with extra networking costs, and also you have to deal with syncing or consistency problems. If you think you can solve all of these problems, there is an additional thing. When you store your operational data in a database and vector information in a different database, what if you want to deal with information like, let's say, you want to search documents. That is, you want to search similar documents from the last 7 days and only for a specific user. In this case, you have to perform similarity search on the vector database, and you have to get user related information from the operational database. So your query should get information from two different databases. Now this becomes a huge challenge for you. I'm only talking about a basic query. Imagine while you're dealing with AI assistant, you will run into challenges where you want to get data from vector database, regular database, and you want to sync that information. If you go with MongoDB, because everything is within a single database, you don't have to deal with this headache. I hope this is clear. Now let's see different use cases in which AI engineers are using MongoDB as their database. One of the popular use case is undoubtedly RAG applications, retrieval augmented generation. Now, when dealing with RAG applications, AI engineers wants to store the documents along with the embeddings together. And also they want to feed results from the large language models. So MongoDB is the best choice for them. Along with it, also when dealing with personalization models like When dealing with personalization models, AI engineers wants to store the user behavior and also the vectors or the embeddings in the same document so that they can match users by the similarities. Also, semantic search is a popular use case where MongoDB is used. Something like search by meaning, not related to the keywords, or basically use vectors as well as filters in the same query. Even in these cases, MongoDB can be quite handy. Finally, recommendation engines as well. Now we all know platforms like Netflix, even food delivery platforms today, they provide recommendations to the users. How do they do it? They compare item vectors and they recommend similar products or videos or the articles to the users. Even in this case, MongoDB can be used as the database for the requirement. So these are popular use cases where MongoDB is used for AI applications. Let me show you through a short demo. Let's say within your e-commerce application, you want to store information of the phones. So you store operational information of the phones along with you store different embeddings of the phones. Let's say the different features of the phone, like the color of the phone, the camera quality of the phone, different features. So how do you do that? First, you create a database. Let's call it as shop database. Now, within the shop database, let's say you create a collection db.create collection. Let's call this collection as products collection. Okay. Within this products collection, let's say you store the phones related information. How do you do that? We learned we will use insert many query because we are going to insert a lot of phones information. I have a sample command here. Once again, you can find this command in the GitHub repository. But let's try to understand what exactly I'm trying to store. So this is the operational information like the name of the phone, price of the phone, and all of these are the embeddings in real time. Whenever you are working with real time AI application, you will find thousands of H embeddings. So usually what vector databases do, or usually in case of AI applications, when you want to store information of the products, you take various features into consideration like color of the phone, camera quality of the phone, the dimensions of the phone, so that whenever user search something, you can perform similarity search using the embeddings or the vectors. That's why you store thousands of embeddings in real time. But because we are doing demo, we will take 4 embeddings. Let's say this is for a particular keyword like camera quality. This is for a keyword for the color of the phone. This is for the size of the phone, etc. So we have 10 different phones here using insert.many. We are storing that in the products collection. There you go. Now we have, if we refresh, you will find the shop database, shop products collection, and within that you will find the operational information and embeddings information in the array format. Cool. Now your database is ready. That is, your MongoDB is ready with all the information. Let's say you are working on an AI application and someone comes to your AI assistant or someone comes to your e-commerce platform and they search for best mobile. Okay, so they search for something like this. Even you must have done it on Amazon or any other e-commerce platforms. Best mobile with good camera quality. Now user did not search for a particular phone, right? If user search for iPhone or user search for Pixel, then you can directly return the results from the operational data itself. But if you look at the information here, best mobile with good camera quality. So this is where what AI applications do. Let's say your AI application is written in Python. So the Python script invokes open AI embedding model or any model that is on your local machine, and it converts this information into the numerical format. So basically it converts it to the embeddings are the vectors. Something like this information is converted to 0.2, 0.3, 0.4 and 0.6. Okay. So the information best mobile with good camera is converted into the embeddings according to the features. And now the AI application runs a query like this on the MongoDB. Of course, it does not use Compass. So it uses maybe the PyMongo or MongoDB client to connect to MongoDB and run the query. But just to show you, I'm using the MongoDB Compass. What happens here? The user's message is converted to the query vector. For that, as I told you, the AI application might be using OpenAI embedding model or any model on the local. Now you can see the results, right? So user just search for best mobile with good camera quality. This is the result from the vector search. So it resulted Pixel 7a, Realme 11 Pro and Motorola Edge 40. So these are the results for the user's message. This is what happens when you search for something on the e-commerce platform. So you are not searching for exact fields that is in the database. You're not searching for Pixel 7 or you're not searching for iPhone 7. You must be searching for best mobile, good mobile. What happens underground? Your application converts that to the query vector and it performs the search on the vector database. In our case, we are using MongoDB as the vector database. Cool. So this is how MongoDB can be used for the AI applications as well. So we learned a traditional use case and we learned a modern use case as well. Or we learned AI applications use case as well. So this concludes our demonstration as well as the MongoDB Zero to Hero video. If you have any questions, do let me know in the comment section. Make sure to check the link in the description as well as pinned comment. Once again, I would like to thank MongoDB for sponsoring today's video. See you all in the next video. Take care.